Bulk plant dispenser components. In order to dispense propane safely, you should be familiar with the equipment you are working with and how to use it. Dispensing equipment often varies from facility to facility. Your bulk plant may or may not have all of the following components: an ASME storage tank that supplies propane to the dispensing equipment, valves that control the flow of propane through the piping system, extra heavy piping and forged steel pipe fittings, a propane pump driven by an explosion-proof electric motor, a platform scale that weighs cylinders during and after filling, automatic pump bypass valves that protect the pump, piping, and hoses against excessively high pressures when the hose end valves are closed and the pump is running, electrical wiring, fixtures, and switches that control the propane pump motor and assist in emergency shutdown, a metering system that measures liquid propane transferred into containers, propane transfer hose assemblies for cylinder filling and ASME tank filling, hose end adapters that accommodate the different valves used on DOT cylinders and ASME tanks, which will be discussed later in the video, an emergency breakaway device for vehicle-mounted containers that is designed to provide protection in case of a pull-away by stopping the flow of gas if a customer drives away with the hose attached, a fenced enclosure, lockable cabinet to secure the dispenser, or devices to secure the valves should be used to prevent unauthorized operation of equipment when not in use. Depending on the site and enclosures, traffic barricades may also be required. Shutdown components. There are two types of shutdown systems. Manual shutdown dispensers stop the flow of liquid into cylinders by manually closing one or more valves. They rely on the operator to determine when the maximum permitted filling limit for a cylinder is reached. Automatic shutdown systems are primarily used where several cylinders are being filled simultaneously, such as a cylinder dock, to reduce the possibility of overfilling cylinders. They normally consist of a sensor or trip lever mounted on the balance beam of a scale and a master control valve that stops the flow of liquid propane to the dispensing hose. The dispenser tank in your facility may be equipped with an excess flow valve in combination with a positive shutoff valve. Internal valves that incorporate excess flow protection are also common and may include thermal and remote shutoff capabilities. Remote shutdown stations may also be installed to provide a greater level of emergency support away from the pump and transfer location. Ball valves control the flow of propane from the supply tank through the piping. A ball valve is open when the valve handle is parallel with the piping. It is closed when the handle is perpendicular to the piping. Globe valves are similar to water faucets and are operated by turning the hand wheel counterclockwise to open and clockwise to close. They must be either fully open or fully closed. Hose end valves stop the flow of propane as part of the container filling operation. As another safeguard against overfilling, hose end valves are quick closing or snap acting. Many also have a safety latch to prevent accidental opening when the valve is not connected for filling. Measuring components. Platform balance beam scales determine when the proper filling weight for cylinders is reached and when to stop the flow of propane into the cylinder. Platform scales can be either single beam, double beam, or digital. All require periodic maintenance and should be checked for accuracy based on the manufacturer's instructions. In many states and jurisdictions, scales must have certification decals from weights and measure officials and be inspected periodically and calibrated for accuracy. Scales must also be leveled and protected from weather, especially accumulation of water, debris, snow, or ice. Purging. In order for equipment to operate properly and to keep customers safe, both new cylinders that have not been vacuum purged by the manufacturer and those that have been opened to the atmosphere must be purged of air or moisture before filling. If air or moisture enters a propane cylinder, it can slow down the filling operation, create unusually high service pressures, cause regulator freeze-up, or cause fading of the odorant in the cylinder. Steps for purging cylinders with propane vapor. Using propane vapor to force the air out of a cylinder is an effective purging method that is often used at refilling stations. Cylinders should always be purged in an approved area where there are no ignition sources. Follow these steps to purge cylinders. Step 1. Connect the vapor hose to the cylinder. Ensure that you have the correct fittings installed when connecting the vapor hose to the cylinder service valve. If the service valve on the cylinder does not have a female POL opening, attach a cylinder service valve adapter to the POL adapter that is installed in the vapor line hose end valve. Securely tighten the vapor hose assembly to the cylinder service valve. Step 2. Pressurize the cylinder with propane vapor to 15 psig. With the inlet valve closed, open the service valve on the cylinder and gradually open the shutoff valve on the end of the vapor hose. If no leak is detected, open the inlet valve. Observe the gauge on the purging manifold until the pressure reaches 15 psig, then close the inlet valve. Step 3. Bleed off the pressure in the cylinder. Slightly open the outlet valve to vent a small amount of propane vapor and air. When the pressure gauge reaches 0 psig, close the outlet valve and open the inlet valve. During this bleed-off process, be very cautious, as a small amount of propane vapor and air will be released. To prevent ignition, venting should be done at least 25 feet from any open flame, smoking area, portable electric tools, and extension lights, and at least 35 feet from any metal cutting, grinding, oxygen fuel gas cutting, brazing, soldering, or welding. Step 4. Repeat the purging process. To be sure that roughly 97% of the air has been purged from the cylinder, repeat steps 2 and 3 at least 4 more times. Leave the vapor return hose connected until the final purging has been completed, then close the inlet valve and repressurize the cylinder. Close all valves, including the cylinder service valve, and check the cylinder for leaks. Never purge with liquid propane. This may cause the liquid to flash into vapor, chilling the cylinder and condensing any moisture vapor on the walls. In addition, only a small percentage of the air will be removed. Steps for purging cylinders with a vacuum pump. Another method for purging air from cylinders is by using a vacuum pump to force the air out. Always follow manufacturer instructions when using this method of purging, and never attach the pump to any cylinder containing propane, since the equipment is designed to only purge air. To properly purge air from a cylinder using a vacuum pump, vent any pressure through a fixed maximum liquid level gauge before connecting the pump inlet hose. Retighten the gauge after the pressure has been vented. Connect the pump inlet hose to the cylinder valve and tighten securely by hand. Open the cylinder valve and turn the pump on. Allow the pump to pull down to 2 psia. Close the cylinder valve, turn the pump off, and disconnect the hose from the cylinder valve. The cylinder is now ready to be filled.